So, good morning everyone. Today I shall discuss about the performance of transmission line. How the transmission line is performed and why we analyze the performance of transmission line. This we analyze. See, when we generate the electric power from the generating plant, and afterward we distribute this power for the particular consumer, for industry, for housing application, for other application. In between this, there are some things are there. By means of this, we can transmit the power. That means this is the way we can transport the electrical energy from one place to another place. That means from generating plant to the distributing station. In between this, as we just transmit the electric power by means of transmission line, so there are some determination is required. What is the determination? That's why we need to perform, we need to analyze the performance of the transmission line. How much efficiency we can get from the transmission line and how much regulation is there. So these are the determination from the performance of the transmission line. If I consider a transmission line, then basically there are three parameters are there which basically affect on the transmission line. One is resistance, another is inductance, and another is capacitance. That means R, L and C. These three parameters basically predominant on the transmission line. When you consider the resistance, basically the resistance loss is there. Which loss is? We drop, first of drop. If I is the current, basically IR drop we can get from the transmission line. Right? After what, inductance. How the inductance drop is there in the transmission line? Which is I multiply XL. XL is the inductive reactance, which is omega L. That means omega means 2 pi F L. Okay. Similarly, there are capacitive drop is also there, which is I multiply XC, which is capacitive reactance. And also we can write this XC means I 2 pi F B C. Okay. 2 pi F B C. That means from here what we can say, here current is the factor. So in quadrature of the current we get the line inductive drop, and here in quadrature of the voltage we get the capacitive drop. So in that way we can just get the drop, not only the voltage drop, again we can analyze the power loss and efficiency and all kinds of things. Now, as there are three parameters are there, the resistance, inductance and capacitance. So how this parameter will influence of the transmission line? So this is the part of the another parameter. But here, how much value parameter will affect on the transmission line? So that we get and we analyze the efficiency and we analyze the regulation of the transmission line. This is the fact. As there are two types of transmission line is there, the overhead transmission line and underground transmission line. Basically, in overhead transmission line, this inductance will affect much more than the capacitance. Whereas in underground cable system, the capacitor will give more effect than the inductance. Okay. So this will come later on. So before this, before going to the calculation of the resistance, inductance, capacitance, and from the performance of the transmission line. So first of all, I will give the details and the different types of transmission line according to based on their level of voltage and the length of the transmission line. Okay. First one, number one, the short transmission line. Short transmission line. Number two is medium transmission line. Okay. And number three is long transmission line. Long transmission line. These are the three types of categories of the transmission line. How is classified? These three transmission lines are classified according to based on the transmission voltage and their length of the transmission line. In case of short transmission line, if the length is up to 50 kilometer, and voltage up to 20 kV, voltage up to 20 kV, then we consider this transmission line is under the short transmission line category. Okay. So here you see, as the length is within the limit and voltage limit, so obviously there are some actually parameters are there. So according to based on the voltage level and the length, we consider the parameters. Which parameters? The resistance, inductance and capacitance. In medium transmission line, here here the length in between 50 kilometer to 100 kilometer. Okay, 100 kilometer. And voltage level up to from 21 kV to you consider the 100 kV. Okay, 100 kV. So you see, the length is increased as well as the voltage level is increased. And if the length of the transmission line above 100 kilometer and the voltage level above 100 kV, then again we consider the transmission line is the long transmission line. So if I consider there are three parameters are there: resistance, inductance and capacitance. In case of short transmission line, as the voltage level is less than the medium and long transmission line, that means here if I draw the diagram of this, see, only resistance and inductance we consider in that case. Here we not consider the capacitance which is formed in between the conductor. Okay. Why? Due to the low voltage, we consider that whatever capacitance is formed, it is negligible and it is considered as large parameter. So only resistance and inductance we consider in case of short transmission. Here this is your sending end voltage, this is your receiving end voltage. Okay. In case of medium transmission line, as the voltage level is increased up to 100 kV, so here we consider, okay, the capacitance is formed in the transmission line. Practically, the capacitance may be formed over through the transmission line. But here we consider in case of medium transmission line, okay, the capacitance may be formed. It may be formed at the sending end place. It may be formed at the receiving end. It may be formed in between the sending end voltage and receiving end voltage. So according to based on this, the medium transmission line again categorized in three different parts. What is it? The T network type transmission line, the pi network type transmission line, and another is end condenser method. End condenser. Okay. So what is this classified? We consider the capacitance here. So thereby the circuit is like a T-type network. Here we consider the capacitance which is formed in both ends. So this circuit is like as the pi-type network. So these are basically method of calculation. By considering this capacitance, we can calculate the efficiency and regulation of the transmission line. In case of long transmission line, here you see the voltage, the length of the transmission line which is above 100 km and voltage is above 100 kilo. That means here there are no way to consider the parameters. As the voltage level is high, so we consider what we think practically whatever capacitance will be formed in between the conductor, this is over through the transmission line. So there is no way to consider the capacitance. So we consider here, we consider there, and we have considered in case of medium transmission line and short transmission line. Okay. So that's why in case of long transmission line, we consider a different method. By means of this, we get the, or we can analyze the efficiency. We can analyze or we can analyze the efficiency also. What is this? Rigorous method. This is the most practical method to calculate the transmission line. Okay. Most practical method. So here I will ask one question to you. See, suppose in case of short transmission line, you get 96% efficiency. Suppose in case of medium transmission line, these are the analytical method. We consider the capacitance. Okay. Here we get 94% efficiency. And by means of this rigorous method, you get 89% efficiency. So which is most appropriate efficiency for the transmission line? Obviously consider this 89% because this is the practical method. Here you analyze by means of considering this line resistance, line inductance, but practically here we not do this. Practically there is some difference are there. Here you consider the idea. Now see. First of all, I will draw one basic diagram of the transmission line. After all, you get what are the parameters are there and all nomenclature of this transmission line. Okay. Here I consider this is line resistance, this is line inductance. Okay. This is line resistance, this is line inductance, XL or L, whatever you write. This input voltage is called sending end voltage. The output voltage is called receiving end voltage. What I have told you, this is the sending end voltage. Here, what I have told you, receiving end voltage. Whatever current you just go through here, so this is called sending end current. At the receiving end, it is called receiving end current. But for that case, we know in series circuit the current flow to each and every component is same. That means here we can say Is equal to IR equal to I. Same. That means Is is the sending end current, IR is the receiving end current. Okay. Now see how we get the regulation from here. That's why I have drawn this circuit. How get the regulation? Whatever the difference in voltage between the sending end and receiving end to the receiving end voltage, this is the ratio. Now you think, as I have told you, this is your regulation. Now you think how the regulation will differ. Suppose the line resistance and inductance are there. This drop is more. The drop more means you get the less voltage at the receiving end, right? So less voltage means the difference of this thing, difference of the sending end and receiving end voltage will get more, and thereby the regulation of the line is poor. That means performance of line is the poor because the line has huge losses. Now you think the drop is very less. Very less means suppose if you consider the 200 to 20 voltage input, you are getting 219 voltage output. That means 1 volt drop is there. So that will represent the line regulation is better. Also, we can determine the regulation considering VR0 minus VR. That means receiving end no load voltage. VR0 means the difference between receiving end no load voltage to the receiving end voltage. To the receiving. you can also get the regulation. Okay. How to get the efficiency from here? If I know the Vs is the sending end voltage, Vr is the receiving end voltage, say, so can you identify from here the input power and output power respectively? What is the basic efficiency? Efficiency means, efficiency means, see, output power to the input power. Okay. What is the output power from here? If Vr is the receiving end voltage, R is the receiving end current, cos phi r is the receiving end power factor to the input power. Input power means Vs, Is, cos phi s. Cos phi r is the receiving end power factor, cos phi s is the sending end power factor. Okay. And also you can get, you know, again we can get the efficiency. If you want to get the percentage, so you can put here multiplied by 100. You can put here multiplied by 100. Again we know the input power can be represented input power output power plus losses. Output power means already you get here IR cos phi r. Losses means how much power losses is there. If I consider this is Rx, so we can put here Z is the impedance, so current I is the current, or you can put here the R is the resistance, you can find I square Z, R square. Okay. So this is the way of calculation of the efficiency. Now one question can come in your mind. In our transmission line, basically all transmission line is distributed in 3 phase, but here I have drawn a single resistance, single inductance. How we do this? See. If I consider this is 3-phase input, okay? 3-phase input. And this is the 3-phase output terminal. Red, yellow, blue, red, yellow, blue. So we connect. So this is the line thing, line resistance and inductance. Blue. Basically all transmission line is 3-phase transmission line. But for our easy calculation, we only consider a single phase. That's why you get this kind of diagram. See. That means 1/3 we calculate the 1/3 of the transmission line. not the total. Whatever power you will get, this is the wanted power. Okay. So is it clear how you get about the performance of the transmission line? And in the next class I shall discuss the all categories of the transmission line, considering the short transmission line, medium transmission line and long transmission line and the phasor diagram respectively. Thank you.